For decades, we've all been taught that the universe is governed by just four fundamental forces. But what if that's not the whole story? A growing pile of evidence suggests there might be something else out there, a fifth force, quietly shaping reality right under our noses.
I mean, really think about that. What if our most fundamental understanding of physics isn't incomplete? What if we've been missing one of the key players in the cosmic game all along? Well, today, we're going to play detective. We're going to follow the clues and see if they really do lead to a brand new force of nature.
So, to understand where we might be going wrong, we first have to get a handle on the official story of physics, the theory we've tested and trusted for more than 50 years. And that story is called the Standard Model. The best way to think about it is like our best map of reality, and it has been wildly successful. I mean, it's explained pretty much every experiment we've ever thrown at it. It even predicted the existence of particles, like the Higgs boson, years before we ever found them. So here they are, the official cast of characters from that story. You've got the quarks up there, which build things like protons and neutrons. Down below are the leptons, like the good old electron. And over in that red column, those are the bosons, the particles that actually carry the forces. This is supposed to be the complete picture, or so we thought. Because here's the problem. As good as this map is, there are huge parts of the universe that it just leaves blank. It's not the complete picture. And we know it. For starters, the Standard Model has absolutely no explanation for dark matter, which, makes up most of the matter in the entire universe. It also says that tiny particles called neutrinos should be massless, but we'd actually proven they do have mass. And look, these aren't small details. These are giant, gaping holes in our understanding. So, as you can imagine, scientists have been on the hunt for what they call physics beyond the Standard Model. And in just the last few years, they've started finding what really look like cracks in the very foundation of this theory we've trusted for so long. One of the biggest cracks comes down to this number, 7 sigma. Now, in particle physics, 5 sigma is the gold standard for a discovery. That means there's only a 1 in 3.5 million chance your result is just a random fluke. Well, an experiment measuring the W boson found it was heavier than the Standard Model predicts, with a certainty of 7 sigma. That isn't just an anomaly, that's a massive blinking red light. And then there's the muon, which is kind of like the electron's heavier cousin. The Standard Model makes this incredibly precise prediction for how much a muon should wobble in a magnetic field. But every time we measure it, the wobble is just a little bit off. And it's persistently off. It's another huge clue that some unknown force is out there, tugging on the particles of our universe. And it's not just one or two odd results either. The clues just keep piling up. Scientists are seeing strange decay patterns in particles called B mesons, hinting they might be interacting with something new. They're getting hints of totally unexpected particles at the Large Hadron Collider, and they're seeing other weirdness in neutrino experiments. These clues are popping up everywhere, all pointing to the same conclusion. Something is missing from our map. Now sure, you could look at any one of these and say, maybe it's a mistake, a bit of random noise. But as physicists Andreas Krevelin and Bruce Mulatto point out, it's getting really, really hard to believe that all of them are just statistical flukes. The evidence is starting to get pretty heavy. Which, of course, brings us to the crucial question. If it's not all a mistake, what could possibly explain all these different anomalies? What is the missing piece of this puzzle? All right, if this is our cosmic detective story, we found our clues. Now it's time to line up the suspects, the new theories that could explain everything we're seeing. And what a fascinating lineup of potential culprits we have. We've got things called leptoquarks. There are Z-prime bosons. Think of them as heavy cousins of a particle we already know. There are also theories about new scalar particles, kind of like the Higgs boson, and even something called vector-like quarks. Each of these theoretical particles could, in its own unique way, explain some or even all of the strange things we're seeing. Let's just zoom in on one of these suspects for a second. Leptoquarks. See, the Standard Model says that quarks, the stuff that makes up protons, and leptons, like electrons, are two completely separate families. They don't mix. But a leptoquark would be a bridge between them, a brand new particle that lets them talk to each other directly. That interaction could be the source of a new fifth force, and it's a very exciting idea. So, we have clues and we have suspects. What's the next step? Well, naturally, it's a global manhunt. A massive worldwide effort to find definitive proof and finally catch our culprit.
And this hunt is happening on so many different fronts. At the LHC, they're smashing particles together, hoping to create one of these new particles and see it directly. Deep in underground labs, they're searching for the faintest signals from dark matter. And in other experiments, they're measuring particle properties with just mind-boggling precision, looking for those tiny deviations that could only be caused by new physics.
But there's another search method that's so creative it sounds like it's straight out of science fiction. Scientists are now using atomic clocks, the most precise timekeeping devices humans have ever built, not just to tell time, but to hunt for a fifth force.
Seriously, this is how cool the search has become. The idea is, if a new force is being generated by the sun, its strength should change as the Earth moves in its orbit, getting a tiny bit stronger when we're closer and weaker when we're farther away. That tiny change could actually cause a tiny annual variation in the ticking rate of an atomic clock. We're literally looking for a new force by watching for ripples in the flow of time itself. Amazing.
So, after all of this, the clues, the suspects, the global manhunt, what's the verdict? Where do we stand in this cosmic case? Let's just bring it all back to our central question. With everything we've seen, can we finally say for certain if there is a fifth force of nature?
The honest answer is, we don't know. Not for sure. Not yet. The clues are incredibly compelling. The theories are tantalizing, but we don't have that smoking gun, that definitive 5 sigma discovery that would rewrite all the textbooks. For now, the case remains open. But here's the crucial point, and this is what's so exciting. We are potentially on the verge of a revolution. As the experts say, confirming even one of these major hints would be enough. It would prove the standard model is incomplete and launch us into a new era of physics, the beyond the standard model age. We're not just looking for a new particle, we're looking for an entirely new map of reality, and that is a mystery worth solving.